Space. It's vast, mysterious, and full of surprises. Every corner of the universe holds secrets waiting to be uncovered. As we gaze at the stars, we're looking at a cosmic puzzle, a grand tapestry woven with threads of light and time. There's so much we're still figuring out. Each discovery leads to new questions, pushing the boundaries of our knowledge. One of the biggest mysteries? The universe seems to be made of stuff we can't even see. This invisible matter and energy make up most of the cosmos. It's like trying to complete a jigsaw puzzle with missing pieces. We have glimpses of the picture, but many parts are still hidden. Scientists call these missing pieces dark matter and dark energy. They are the unseen players in the cosmic game. Don't let the names fool you. They're not evil or scary. They're just terms we use to describe what we don't yet fully understand. They're just invisible forms of matter and energy that we haven't fully understood yet. Their presence is inferred from their gravitational effects, but even though we can't see them, they have a huge impact on our universe. They shape the structure and behavior of galaxies. Imagine a giant game of cosmic tug-of-war. Forces we can see and those we can't are constantly interacting. On one side, we have the gravity of everything we can see: stars, planets, galaxies. These are the familiar players. On the other side, we have the mysterious forces of dark matter and dark energy, pulling and pushing on the universe in ways we're still trying to understand. They are the hidden influences. These invisible forces shape the cosmos, influencing how galaxies form and how the universe expands. They are the architects of the universe's grand design. Unraveling the secrets of dark matter and dark energy is like discovering a whole new set of rules for how the universe works. It's a journey into the unknown. It's a thrilling detective story on a cosmic scale. Each clue brings us closer to understanding the true nature of our universe. Let's start with dark matter, the invisible glue holding the universe together. Imagine a spider web, its delicate strands connecting everything. Dark matter is like that, a cosmic web that provides the gravitational scaffolding for galaxies to form and stay together. We can't see dark matter directly. It doesn't emit light or energy like the stars and planets we're familiar with. So how do we know it's there? It's all about gravity. Dark matter's presence is felt through its gravitational pull on visible matter. Think of a merry-go-round. The faster it spins, the stronger the force that keeps you from flying off, right? Similarly, galaxies spin at speeds that should fling stars outwards, but they don't. Something invisible must be holding them together, and that something is the gravitational pull of dark matter. There are other clues to dark matter's existence too, beyond just the gravitational effects we observe. One significant clue comes from a fascinating phenomenon known as gravitational lensing. Imagine a bowling ball placed on a trampoline. The ball creates a dip in the fabric, right? This is a simple analogy to understand how gravity works. Similarly, massive objects like galaxies warp the fabric of space-time around them, creating a sort of cosmic dip. This warping can bend the path of light passing by, acting like a giant cosmic lens, magnifying and distorting the images of distant objects. Astronomers have observed light from distant galaxies being bent around galaxy clusters in ways that can only be explained by the presence of much more matter than we can see. Dark matter, this invisible matter, exerts gravitational forces that affect the light's path. Another compelling clue comes from the cosmic microwave background radiation, the faint afterglow of the Big Bang which permeates the universe. This radiation contains subtle temperature variations that provide a snapshot of the early universe, revealing the distribution of matter and energy shortly after the Big Bang. These variations suggest that dark matter was present from the very beginning, playing a crucial role in the formation of the structures we see today, such as galaxies and clusters of galaxies. Without dark matter, the universe would look very different. Now, let's talk about dark energy, the mysterious force that's accelerating the expansion of the universe. It's one of the biggest puzzles in modern astrophysics. Imagine baking a loaf of raisin bread. The dough represents space and the raisins represent galaxies. As the dough rises, the raisins embedded in it move farther apart. This is similar to how galaxies move away from each other as the universe expands. Similarly, the space between galaxies is expanding. And surprisingly, this expansion is speeding up. This acceleration is what makes dark energy so intriguing. Something must be counteracting gravity, pushing everything farther apart, and that something is dark energy. It's like an invisible force that's reshaping the cosmos. We know even less about dark energy than we do about dark matter. It's one of the greatest unknowns in our understanding of the universe. It's like trying to understand the rules of a game by watching it from a distance without knowing how the players move or what the goal is. We're still piecing together the clues, but we do know that dark energy makes up the vast majority of the universe, a whopping 68%. This means it has a profound impact on the fate of the cosmos. It's the dominant force shaping the cosmos on the largest scales. Understanding dark energy is crucial for unraveling the mysteries of the universe.